Hey everyone, welcome to the final video in our Year 8 measurement series. Now, as I've mentioned numerous times on this channel, with these video series, especially as we get into the later years, we're only looking at really the new topics that come up in these particular years. So we've looked at volume before. If you haven't seen that, you can check my series on measurement from the Year 7 course. Now, with volume, I've gone in detail in previous videos about how we come to understand volume, what we mean by that. So this video is more just going to jump straight into solving problems with finding the volume of prisms. And the reason this is in this series is because we're looking at a new thing, and this is finding the volume of cylinders. And we're going to also distinguish between prisms and cylinders in this video. So I'm actually going to talk about that now. So when we think of a prism is really just any solid shape with flat faces and flat surfaces. So there's no curving happening here. And what's important to note with prisms is that they usually have one shape, or two faces, I should say, shapes on the faces, which are identical. Now, let's actually talk about that a little bit more in detail. Now, I'm going to do this in a different color. But here, when we look at prisms, that just means there's a couple of things like we talked about. It's going to be a solid 3D shape because with volume, we're looking at 3D shapes. And two of the faces are going to be identical. So, for example, we've looked at these before. This is what we call a rectangular prism. Why do we call it that? Well, the face is a rectangle. So we have a face here that's a rectangle, and that goes all the way through the shape to this back part of the prism as well. So what we mean by that is that if I were to slice this prism in half, so if I say cut it here and I slice this whole chunk off the front here, I would get, once again, the same shape going through. I would get the exact same face here as I would at the back and all the way through this shape. Now that thing there, the front face, these identical faces on each side, we call that the cross section. So let me label that here. This thing is what we call the cross section of a prism. And let's center this actually. Prisms don't just have to be these rectangular ones. For example, you can also get a triangular prism. So this thing here has, for example, instead of a rectangle going all the way through it, it has a triangle going through it. This is like if you're, I don't know if where you guys are from have this, but in Australia where I'm from, we have this chocolate called Toblerone, and it has this particular shape. It's like a triangular prism, and as you break it off, you get these triangles going all the way through. And you can kind of see that here, hopefully, where you have this front face, which is a triangle, and you can see the back face is identical to that. That is what we call a cross section. And if we have, as long as we have these straight lines sort of all the way through, wherever we slice this prism, whether it's say here or here or here, the face that's always showing is going to be my triangular face. So that is also going to be a cross section. Now, these can be any shapes, right? Another one here, for example. I'm going to draw a trapezium. So this is, for example, what we call a trapezoidal prism. And you can see it goes all the way through. It is a trapezium. So the front face and the back face are identical. That's what we require to call something a prism. And you can see all the way through, no matter where I cut this, my cross section, my face that goes all the way through my shape, is this one right here. Now, this brings us to coming up with the actual formula for volume. And if you remember from my previous series, all we had to do was find the area of the cross section, that front face, and multiply it by the depth. So here, for example, our volume would be whatever this cross-sectional area was multiplied by the depth here. And we call that H when we talk about volume. Hopefully this will all be a revision from the previous video. So when we're dealing with prisms, our formula is going to be, our volume formula is going to be the area, the cross-sectional area times the height. And the dimension of the shape, the side we mean for the height, is just the one going away from the cross-sectional area. So in all of these shapes, I have whoops, let's do that in a nicer color. I have my height here, the one that's going away from my cross-sectional face. In other words, a good way I like to think of it is that if we tipped, for example, this triangular prism onto its face. So if we put this triangle on the ground, if we had this as a shape, the height of that thing will be the length between the two identical faces. Same with this trapezium, right? If we put it on this green face on the ground, if I sat this 3D shape on the ground, then the height of it is going to be this again. That's a good way we can think about it. So for our volume, to find that, we multiply our cross-sectional area, so that face that goes all the way through the shape, and we multiply that by the length going away from the cross-sectional area. So I'll call that height here, and I'll put in brackets length from one identical face, to the other. So that is how we can think of volume. Now, let's look at one example of this, and then we'll talk about cylinders. Now, I'm going to draw a triangular prism for my first example, and I'm going to be using this formula that we came up with. So this is my, that's my volume formula. Okay. Now let's look at how we can use this here. So example one, I'm going to draw a triangular prism, and you'll have to excuse the bad drawing. Just pretend that this looks a little bit better for the sake of this question. Now, I have a triangular prism, and my height here is 2 meters, and I have a 4-meter long base, and my length here is 8 meters. So, in approaching these questions, we're always going to look at them the same way. The first thing we're going to do, step one, is going to be to find the cross-sectional area. Let me write that as CA for CS for cross-sectional area. And then for my second step, we just want to apply the formula. So apply the formula that we looked at before. So we want to find the volume by timesing my cross-sectional area by the height. And we're going to do that for the majority of these questions. So I ask you guys, what do you reckon the face is? Take the cross-sectional area, the identical faces. You can think this over at home. Well, it's not going to be this one here, is it? Because that doesn't go all the way through the shape. It's not going to be this one. That'd be weird. It's not going to be this one either. The two identical faces are the ones that I have here. The one at the front and the one at the back. So that means that no matter where I slice this, I'm always going to get a triangular face showing. So this is the cross-sectional area that I want to find. So my cross-sectional area equals my triangle. And how do I find the area of a triangle? Well, I take the base, multiply it by the height, and halve it. So I do half times base times height. And now I just want to substitute in my different things here. And now it's important here because I know I've used height here to show the length going away. This is where it gets a little bit confusing, but my H here is different to the one up here. The height I'm looking at here is the perpendicular height. This is just for finding the area of a triangle. So I'm looking at the perpendicular height of the triangle. So this thing right here. So this is my perpendicular height. So to find this, my height here, let's draw that a bit nicer. This one here, well, that's going to be my 2 meters. And my base that I substitute in is going to be 4 meters. Now, putting that in, I get 4 times 2 times a half. So let's actually write our next line of working, make this look nice. I have half times 4 times 2. And that gives me 4 meters squared. I have found my cross-sectional area. Now, what do I want to do? Well, I want to just multiply that by the length that joins the two faces. So my 8 meters here. So that is going to be the height in the volume formula. So I can say, therefore, my volume equals my cross-sectional area times the height being the length between the two identical faces. And I already know these two values. I have 4 meters squared as my cross-sectional area, and I'm multiplying that by 8 meters, this length going away from my front face, the height if I tipped this face on the ground. So I multiply that by 8 meters, and because I'm finding the volume, I'm going to get 32 meters cubed here. Okay, that's how we'd find volume. This, for most of you, should be revision, but let's just quickly take a look at cylinders. Now, cylinders look kind of similar to prisms. Cylinders. But you may notice they have curved edges. So a cylinder has curved edges. So these ones here, this one here and this one here, and all this space along here it curves around. It doesn't have these straight lines like a prism would have. But we can apply our volume formula in a very similar way, because just having a look at this, can you see any two identical faces and possibly a cross-sectional area? Well, I see, for example, a circle here and a circle here. And if I sliced my cylinder at any point, whether it was here or here or here, I would always get a circular face showing. So my cylinders have a circular cross section and they have some height, some distance from one identical face to the other. And the cross-sectional area is that of a circle. Cool. So let's apply this to a question, because in this video series, we've learned how to find these areas of a circle. This isn't too daunting, hopefully. Now, let's try one example and we'll wrap up because I'm going a bit over time here. But we apply the same formula for the volume of a cylinder. We still multiply my cross-sectional area by the height. The only difference here is that my cross-sectional area is that of a circle, not a trapezium or triangle or these shapes that we looked at in our Year 7 measurement series. So, taking a look at another question, let's look at this cylinder here. And it has a radius of 2 meters and a height of 10 meters. So once again, I have a cylinder with a circular cross section. So I want to find first the cross-sectional area. So the cross-sectional area equals, well, how do we find the area of a circle? Well, if you remember from our last videos, we take this number pi, we multiply that by my radius squared. So I'm going to do pi times r squared. And what's my r, my radius? It's my 2 meters here from the question. So I'm going to do pi times 2 squared. And let me pop that into a calculator. If you remember, pi is an irrational number, so it's going to give me a lot of crazy decimal points. It's not going to be a nice number. So I'm going to find this to 1 decimal place. So that gives me 12.6 meters squared to 1 decimal place. Now that I have the cross-sectional area, guys, all I want to do is multiply that by my height. So this thing here, my 10 meters, is my height from one face to the other. So my volume is going to be my cross-sectional area. I've already found that, 12.6 meters squared. And I multiply that by the height. So I multiply that by 10 meters. And once I do that, I'm going to get 126 meters cubed. And now, because I just rounded this to 1 decimal point here, when I multiply this by 10, I'm just going to get an integer. This is just what happens when we round. So I've just covered finding a bunch of different volumes. So now, by the end of this video, we will be able to find the volume of any cylinder at all, as well as any prism. And we saw before, prisms come in a variety of different shapes and sizes like we have here. But to approach all of these questions, we always come back to this formula, that my volume, I can find that for prisms and cylinders by multiplying the cross-sectional area by the height. Thank you so much for joining me, guys, and I'll see you in the next series.